Most people assume that timber preservation is a modern concern, something that began with industrial chemicals, pressure treatments, or sophisticated coatings. The reality is far older and far more practical. For centuries, human societies developed methods to make wood last decades, even centuries, using logic, observation, and careful material selection. What is overlooked is not just the methods themselves, but the mindset behind them. Our ancestors treated wood as a resource to be managed with the same precision as food, water, or stone. This wasn't about aesthetics, it was about survival. The consequences of neglecting such understanding were severe. Structures would fail, tools would rot, and entire communities could face critical shortages. Yet, the principles they applied resonate today, offering lessons for anyone concerned with durability, sustainability, or living in harmony with materials. Our ancestors knew wood was alive long after it was cut. Now, one common misconception is that timber becomes inert the moment it leaves the tree, but actually historical accounts and archaeological studies tell a very different story. Freshly felled wood continues to respond to moisture, temperature, and microbial activity. In Viking longhouses, medieval barns, and Japanese temples, the choice of harvest season, drying location, and stacking orientation really dictated whether a beam would endure or, fail within just a few years. Northern European builders, for example, favored winter-cut oak because lower sap content and reduced insect activity minimized decay during drying. The Japanese developed complex air-drying systems, often under shaded, ventilated structures, to slow moisture loss gradually. The principle was consistent: treat timber as living material that needed time and environment to stabilize, rather than simply as a commodity to be used immediately. The logic of simple preservation methods often outweighs complex treatments. Before chemical preservatives existed, societies relied on accessible materials with preservative properties. Pine resin, for instance, was commonly applied to ship hulls, roofs, and fence posts in Scandinavia. The resin acted as both water repellent and deterrent against fungi and insects. In coastal Norway, boat builders would soak timber in salt water before assembly. Salt, while inexpensive, created an environment hostile to decay organisms without altering the structural integrity of the wood. Archaeological studies of Viking ships, such as the Oseberg ship, revealed timber that survived over 1,000 years because of consistent exposure to controlled conditions, not chemical innovation. These strategies really illustrate a critical principle. Effective preservation doesn't actually require advanced technology. What it does require is a careful understanding of environmental interactions and, of course, the material itself. Stacking, seasoning, and airflow, well, those were deliberate choices, not just accidents. The way timber was stored was honestly a decisive factor in its longevity. Builders would stack beams with spacers, sometimes called stickers, between the layers to allow air circulation. This in turn prevented the growth of mold and reduced warping. In France and Germany, historical records show that oak intended for high-value construction could remain in storage for 5 to 10 years before use, and sometimes even longer for monumental projects like cathedrals or bridges. The purpose was not merely drying, but conditioning. Slow, even moisture loss stabilized the wood, reducing internal stresses that would otherwise lead to cracks or split beams once installed. The lesson here is, simple yet profound. Patience and planning in material handling dramatically influence performance. Modern builders frequently underestimate this, leading to failures that could have been avoided with basic principles that were well understood centuries ago. Different woods required different approaches, and they were documented. Not all species behaved the same way. Softwoods like pine or larch needed less seasoning than dense hardwoods such as oak or chestnut. Japanese craftsmen distinguished between heartwood and sapwood, knowing that the inner, denser heartwood resisted insects and decay, while the outer sapwood required additional treatment. In Europe, guild records from the 14th century often detailed which types of wood were appropriate for particular structures and how to store them during winter and summer months. This knowledge was empirical, accumulated over generations, and shared through apprenticeship. Modern gardening or carpentry manuals rarely emphasize such nuances, yet they can mean the difference between a beam lasting decades or failing within a handful of years. Water management was always central to preservation. Perhaps the most overlooked lesson is the subtlety of water management. Our ancestors didn't merely protect wood from rain, they managed water within the wood. Builders oriented timber in storage so that moisture gradients were minimized, often under lean-to shelters or within covered stacks. Roof overhangs, foundation drainage, and even placement of posts in soil were informed by a keen understanding of water movement. In medieval England, the use of gravel beds under fence posts prevented contact with saturated soil while still allowing adequate drainage. Timber immersed in slow-moving streams, as practiced in some Scandinavian regions for beams intended for bridge construction, absorbed tannins from the water, which acted as a natural preservative. These examples highlight an enduring principle. Preservation isn't passive. It is an active engagement with the environment. Timber preservation wasn't only about material science, it shaped architectural decisions. Heavy beams were often oversized intentionally, knowing that drying and shrinkage would reduce load-bearing capacity slightly over time. In Japanese temple construction, mortise and tenon joints were designed to accommodate slight dimensional changes without compromising stability. In Europe, shipbuilders accounted for resin loss and warping when shaping keels and ribs. Every choice reflected an awareness of material behavior and a willingness to plan for uncertainty. This mindset resonates with survival and resilience thinking. Anticipate decay, plan redundancies, and align human design with natural processes rather than against them. Protection from fire, insects, and rot wasn't incidental. In the Russian north, log homes were chinked with clay mixed with organic fibers, which provided both insulation and pest resistance. European barns sometimes included floor beams coated with linseed oil or tar to repel wood-boring beetles. Foundations were elevated on stone pads to prevent contact with damp soil. Across cultures, the theme is consistent. Preservation was integrated into construction, not added afterward as an afterthought. Modern shortcuts, chemical treatments without design consideration, can never match this holistic approach. The logic of timber preservation offers more than historical curiosity. For anyone interested in sustainable building, disaster preparedness, or off-grid construction, these methods are practical. They emphasize patience, observation, and the effective use of local resources. They show that centuries-old timber, if harvested and stored with knowledge, can remain structurally sound without modern chemicals. Beyond survival, these techniques reveal the empirical mindset of our ancestors. Careful observation, incremental improvement, and documentation pass through apprenticeship and craft traditions. That approach allowed societies to reliably store critical resources and construct buildings capable of withstanding generations of environmental stress. Modern engineering often focuses on synthetic solutions, overlooking empirical wisdom embedded in centuries of practice. When we study historic timber, the most striking discovery is not the absence of rot or collapse. It's the sophisticated understanding of material behavior under changing conditions. The principles are consistent: control moisture, allow for gradual changes, protect vulnerable surfaces, and match species to function. For historians, the lesson is that survival and resource management were deeply intertwined with daily life and construction practice, and for anyone applying these lessons today, whether in building or restoration, the strategies remain valid. Ignoring the logic of our ancestors comes with costs. Buildings fail faster, materials degrade sooner, and we lose the opportunity to learn from centuries of observation. Preserving timber was never about convenience. it was about reliability and longevity. By understanding how earlier societies approached these challenges, we gain insight into both human ingenuity and sustainable resource management. We also gain perspective on resilience, risk management, and patience, qualities that are, honestly, often undervalued in modern construction and resource use. If you value careful historical analysis and want to explore more lessons from the past that inform how we live, build, and survive, subscribe to History Vault and share this video. Understanding these overlooked strategies isn't just about looking back. It's about learning from the past to make smarter decisions today.